Today, we're going to conduct a thought experiment that challenges our imagination while at the same time being scientifically grounded. What if we could travel at trillions of times the speed of light? Could we reach the farthest corners of the universe at that speed? How would fundamental laws like causality be affected? Let's explore together where this crazy speed could take us. Trillions of times the speed of light. Suppose for a moment that instead of 300 million meters per second we could travel at 10 septillion, that is 10 trillion times trillion meters per second. This would mean that we could travel a distance of 1 billion light years every second. At that speed, imagine that we could reach the farthest corners of the universe in a matter of seconds. However, if this dream were to come true, we would turn the laws of the universe and the basic rules of logic upside down. Causality and the reverse flow of time. Exceeding the speed of light would violate basic laws of logic, such as causality. For example, we would see the glass shatter before you threw a stone at it, and the stone would break the glass after it left your hand. Such events would completely change the order of the universe and the relationship between events. Journey to the farthest corners of the universe. Traveling at this incredible speed, we could reach the Eridanus supervoid in 1 second, the Great Wall of Hercules Corona Borealis, the largest group of quasars in the universe, in 9 seconds, and the galaxies visible in the Hubble telescope's famous Deep Field image in 13 seconds. At 14 seconds, we would be at the edge of our Hubble sphere, at which point the galaxies we observe would be moving away from Earth at the relative speed of light. Just past the Hubble sphere, every galaxy we see would be moving away from the Earth faster than the speed of light. Earth's event horizon. Just 2 seconds later, we would reach the event horizon of the Earth, the region of galaxies that Earth observers would never see. The galaxies you see after this point would never be seen by Earthlings in their present form. However, these galaxies could still be observed by Earthlings in their old form. Limits of the observable universe. At the end of 46 seconds, not even a minute into our journey, we would reach the limits of the observable universe. At this point, which is the limit to which the photons emitted since the Big Bang can reach Earth, humanity would not be able to see a single moment of any galaxy beyond this limit. Due to the expansion of the universe, every second 20,000 more galaxies were moving away from our horizon and becoming invisible to humanity. Just imagine every second 20,000 galaxies disappear from our horizon, along with billions of stars and planets. But what would happen if you, as a being capable of violating the laws of the universe, traveled with these galaxies outside the observable universe? You would see more galaxies, more space-time, as you continue your journey. But how far can this journey go? The limits of the universe. The total size of the universe can have very different values. At best, it could be only 250 times larger than the observable universe, in which case you would have an 8-day journey ahead of you. At worst, it could be 10 times 10 times 10 times 10 times 122 megaparsecs in size. This is such a huge number that even traveling at 1 billion light years per second would not be enough to cover this distance. The infinity and geometry of the universe. The question of whether the universe is infinite depends on 3 fundamental properties: its geometry, curvature, and connectedness. Whether the universe is flat, positively curved, like a sphere, or negatively curved, like a saddle, determines the answers to these questions. The most precise measurements to date show that the universe is flat. This means that the total energy of the universe is 0. Geometric properties of the universe. If the universe is flat, lines that start parallel remain parallel forever, and the sum of the interior angles of triangles is 180 degrees. If the universe is positively curved, the parallel lines converge and the sum of the interior angles of the triangles is greater than 180 degrees. If the universe is negatively curved, the parallel lines diverge and the sum of the interior angles of the triangles is less than 180 degrees. The future of the universe depends on the density parameter and the vacuum energy. If the density parameter is less than 1, the universe will expand forever. perhaps tearing itself apart. If it is greater than 1, at some point the universe will stop expanding and collapse in on itself. However, due to dark energy, the expansion of our universe continues at an accelerating rate and could last as long as 500 billion years. Whether the universe is simply connected determines whether the universe is infinite. If the universe is simply connected, it could be infinite. However, we don't know the exact shape and size of the universe, and mathematicians are still working on these issues. This thought experiment helps us understand the complexity and size of the universe. Traveling at trillions of times the speed of light means pushing the boundaries of the universe and violating its fundamental laws. While this is only possible in science fiction novels and in our imagination, it is an important thought exercise to understand the true nature of the universe. See you in the next video. Bye.